Okay, so here we have a question about SHM, and we've got a graph showing the variation of time with acceleration. Here it is. It's a kind of sine graph, and it says define simple harmonic motion. Okay, so we know that simple harmonic motion is where the acceleration is proportional to distance from a fixed point and always directed towards that point. Okay, now question part B. X has a mass of 0.28 kg, find the maximum force. So to do this, we need to find the maximum acceleration. That's on the graph here, 2.6 meters per second squared. So we're going to use a very familiar equation, F equals ma, and get 0.28 times by 2.6. And that gives us a force of 0.73 newtons. All right, determine the maximum displacement of x, also known as the amplitude. So to do that, we need to use the equation which is maximum acceleration equals minus omega squared times the amplitude x naught. Now, omega squared we have to calculate, and we can do that by saying that t is 2 pi over omega. So omega is 2 pi over t. Now t is going to be our value for the time period, and you can see here this is one oscillation, and it comes in just between this point here and this point here. Now this point is 6.4, 6.8, 7.2, 7.6. And this point is obviously 8.0. So it's looking like that line crosses about 7.9. It's very, very close. So we can do divided by 7.9 for our value for t. And that gives us a value for omega of 0.795. We then put that into our equation together with our value of a naught, which we saw earlier, and we get x naught equals 4.1 meters. Because of the uncertainty involved in reading a graph, values between 4.0 and 4.25 meters are acceptable. So you didn't have to have it right on the nose. These marks are okay too. All right, part D. The second object, y, oscillates with the same frequency, but phase difference of pi by 4. Sketch using the graph opposite how the acceleration of the object y varies with t. So we're going to have to draw on this graph that I've kind of drawn on a lot already. So let's just remove that line. Let's remove this. So pi by 4. Now, if it was pi, that would be perfectly out of phase. So pi phase difference would be in antiphase, looking like that. Pi by 4 then is halfway between this point and this point, so somewhere around here. Of course, it could be before or after that peak, so it could also be here. So when we're drawing the graph, we could draw this line, in purple, or we could draw this line in orange. Like that. So let's just tidy that up a bit and show the two possible lines that can be drawn for pi by 4. In orange we could have it about here. Oops. That line would be fine. Or in purple we could have a phase difference of pi by 2 behind the drawn line, like that. So either the orange line or the purple line, they would be fine.